Welcome to Power Channel TV. Every Friday, 3 p.m. Eastern, noon Pacific, your opportunity to spend a little time with us at Briggs & Stratton to learn from topics from marketing to innovation to technology and technical items. This week's topic, EFI Systems Overview. Now, if you're a dealer who's sold a few units, or maybe you know you're going to be seeing some of these units, this is a great opportunity for you to get an overview of the different components in the EFI system, what they do and what part they play. Today I've got with me Tom Billigan, our instructor manager here at Customer Education at Briggs & Stratton, and he's going to be covering with you that EFI Systems Overview. So sit back and let's spend a little time with Tom.
Thank you, John. All right, well, good afternoon, everybody, or good morning. What we're going to embark on here is our Delphi fuel injection system here. You probably have all caught wind by now that we obviously have a pair of V-twins with electronic fuel injection. So what we kind of want to do here is take a moment to get you familiarized with what it's about, what it does, and most of the components involved here. Okay, so it gets you some level of understanding and familiarization with this. We will have future video content here that we're going to be putting out on the Power Channel TV here in the upcoming weeks that will dive into more of the troubleshooting aspect of it. So I'm going to stay away from the troubleshooting today, but we will be definitely hitting those points into the future. Now, in case you're not familiar here, the engine families that you'll find fuel injection on are Vanguard engines only right now. Our engine pictured over here is what we call the 810 EFI. This is an engine that's built at our Auburn, Alabama plant. You would have recognized it from our update seminar this year. This is one engine that carries the fuel injection system on it. The other is the big block marine application right now. So those are the types of engines you'll find on mud boats branded typically ProDrive, Boss Drives, and Gator Tail are the biggest players using that particular engine right now. There are a little bit of differences in components there, but as a whole the system is identical here regardless. What I have in front of me here is a training board that we typically will use in a fuel injection training school. Now, it's the entire system laid out here on a board, so you don't have to climb all over an engine to find it. However, during the session here, I am going to reference my 810 engine over here in terms of location to kind of build your familiarity here and recognize that most of the parts are typically centralized around the front of the engine, regardless of what engine family you're dealing with here. Okay? So let's start out with some of our components here. First one I'm going to start out with is our ECM, or Engine Control Module. Now, that is the brain of the system here. All things begin and end here with engine operation. Its location on the V-twin 810 over here is right above the number 1 valve cover. So you can see it looks the same as it does on my board. Here's your 2 ECM connectors, and it's right above this valve cover. Pretty easy to get to. Okay? So what this thing does is it sends out commands to different components based off of inputs from other sensors. So really what it's in charge of is running our ignition coils. Okay, this is in charge of adjusting timing advance all the way from about 8 degrees clean up to 45 degrees before top dead center, depending on what the engine requires at that moment in time. Now, it's also in charge of fuel delivery as the other side of fuel injection. So of course we have a pair of fuel injectors. I'll explain those in a minute here. But what we load in here, what makes it unique to every particular engine model family, is an item we call a calibration. It's really the set of instructions we load in from the factory to run that particular engine. Now that's the part, again, we swap out depending on the engine model type and trim and everything and the type of application it's going into. So it's not a one-size-fits-all situation here. Okay? The next component I want to talk about, or there's actually 2 of them, is our fuel injectors. All right, they're typically housed in our intake manifolds here. Now, we're working on an 810 EFI example here, so I have my metal intake manifold as well as my fuel injectors over here. Now, this is what we call a multi-port fuel injection system. Not to be confused with direct injection, that's a completely different technology. But how these things are worked is the ECM will run these. Okay, it will basically take commands and operate these things in what we call pulse width, and it's usually measured in milliseconds. Now, the angle in which these things are mounted into the intake manifold really is meant so that it points straight down the intake runner right at the intake valve stem, so that we have the best chance of getting all of that fuel we're putting into the airstream into the combustion chamber. And then the ECM's smart enough to only time the injection happening when the actual intake valve is open. So there's no wasting, we're not puddling it behind a closed intake manifold. It's what we call sequential injection. All right, jumping up to our next series of components here are ignition coils. Now, these operate in a different manner than any other Briggs engine coil that you would have dealt with before. These are operated with 12-volt battery power. Now, by contrast, almost all of our engines that are carbureted will have a induction-operated ignition system. So meaning the fact you have a magnet on the outside of the flywheel, comes past the ignition coil, creates an electricity, and steps it up through all the different copper windings inside of here. Well, those components are gone, and as mentioned, we got 12-volt battery power routed into these. So anytime the ignition key is on in the run position, these things are live at 12 volts all the time. So at that point, it's waiting for the ECM to close the ground to make the coil operate and fire our spark plug here at the proper time. Okay, so that's how we depart from a difference in ignition systems here from a carbureted engine too. All right, next up is our fuel pump module. Now, this device sets on the opposite side of the engine from where the ECM is. You can't see it pictured over here, but it's over on the other side of the engine where the yellow oil filter is. You can kind of see it poking out the bottom over there. All right, it's mounted directly above that, but straight below the oil cooler. You're also going to find that there is a built-in Schrader valve there for testing fuel pressure. No longer do you have to connect in any sort of tools in terms of making a point in which you can even check the fuel pressure. It's already built in from the factory. All you do is thread on a fuel pressure test gauge and you're done. Okay? Now, this electric fuel pump module is sort of unique. Of course, it's where the electric fuel pump lives, but there is also a vacuum-operated pulse pump on the 810 engine that fills this thing full of fuel. The electric fuel pump inside is great at sending out high pressurized fuel in volume, but it's not good at lifting fuel from the gas tank, so it needs a little helping hand in between here. Okay? If you're working on a big block engine, you're going to find that it has an electric lift pump in line to fill this pump module, not a vacuum-operated one like the 810 has. Okay? Moving over to the side of it here, I have what we call our crankshaft position sensor. Now, this is arguably one of the most important sensors on here because really if we lose it, the engine doesn't run. All right? This is where we derive engine speed from, and also it works in conjunction with a flywheel on the engine. All engines will have some sort of flywheel, but we have 23 equally spaced teeth around the outside diameter of the flywheel. It is not the starter ring gear teeth. These are actually above it by about an inch. And the 23 teeth swing past here and create a little bit of AC voltage that the ECM interprets as a count. Okay? Every tooth creates one count. And there's the space of about 2 that are missing. So you've got a blank spot in the middle of these 23. That tells this system, hey, you made 360 degrees of revolution, turn around and start over again. Okay? So again, a pretty important sensor. If we lose this, we have no fuel or spark because the engine doesn't know where to begin its operation cycles at. Okay? All right, moving back over here towards the intake manifold itself here, I want to talk about a couple different sensors here. One of which is located right here in the top of the intake manifold. This is what we call a T-MAP sensor. Now, this is a temperature sensing MAP sensor, so it's 2 sensors in one body. The air temperature side of it we call MAT, manifold air temperature. That is used to monitor air temperature coming into the combustion chamber, so if we have to make any tweaks to ignition timing advance, we may have to bring it back slightly if the air is too hot so we don't run into detonation issues. And then it's also used for helping the cold weather startup function here too. Now the MAP sensor side of this, you've probably all heard of this term before, manifold absolute pressure or manifold air pressure. Inside of this sensor there's a diaphragm that moves up and down based off of how much manifold vacuum we have. That paints the picture of how much workload is being done by the engine to the ECM. The ECM interprets that and says, okay, this is how much fuel I need to deliver, and here's how much spark advance I can put at the engine at this given RPM and this given workload. Okay, so that's a pretty important sensor. And it paints a pretty broad brush here for everything functionality-wise on the engine. All right, just behind the intake manifold here is what we call the EHT, engine head temperature. It's this little silver barrel down here. Now we lifted this from our electronic fuel injection or electronic fuel management engines, which is electronic choke. So this is a thermistor that sets down on the number 1 cylinder head, and that's how we derive instantaneous engine temperature. So we use that for a couple different functions. For engaging closed loop functions, which we'll touch on in a moment, as well as it's sort of a safety net. So we'll use it if the engine begins to get into an overheat situation. We can enrich in the mixture through the ECM. It can recognize that and help to try to cool the engine off from the inside out by running it overly rich. Okay? All right, moving over here to a different quadrant on the board is our oxygen sensor. Now, there's that buzzword I used before, which is called closed loop. Now, anytime you hear that particular term, that means there is an oxygen sensor in the exhaust system that reports feedback. This closes the loop and tells the ECM exactly how in fact it's actually using the given air and fuel ratio. Now, when this sensor is in function, it's not all the time. When you hit warm-up periods, it will engage. Typically about 125 degrees of engine head temperature, the ECM will turn this thing on and start taking it for granted as to what's coming out of it. Now, when it's engaged, it's trying to target an air-fuel ratio number. That number is typically 14.7 to 1 air-fuel ratio. That's the theoretical perfect burn rate for gasoline or stoichiometric. And it's consequently where we get the best fuel economy. Your cars or trucks driving down the road are going to run at that controlled air-fuel ratio with the help of oxygen sensors. So if there's any deviation, this thing's job is to tell the computer, hey, I'm like 5% too lean down here. I need a little more fuel from you to make sure that I'm happy down here in the muffler. Okay, it has quite a range. It can go up plus minus 25% worth of correction, either adding or taking away. So it's got quite a bit of authority. All right, next component right behind it here is our diagnostic link connector. This is where we do all of our diagnostic information with the engine. Now, this typically has an orange cap on it, and this is not similar to any of our competitor engines. This is lifted straight from the marine industry, which is what we think makes the most sense here. So actually, I'm going to take an opportunity to show you one of our scan tools here that plugs into this. So what we have here is a TinyScan. This is our own homemade, not homemade, but it's made by Design Technology Inc., but it's our own in-house sort of design here, where we plug into the engine, it reads the digital code to you, the diagnostic trouble code, and allows you to clear it afterwards instead of having to go through the blink code function. So I'm going to demonstrate it to you. I am going to turn the board on. My check engine light is on, now doing a self-test when it's running. Now I'm going to run the board, and I should see my check engine light illuminate here eventually once a code becomes present. Disconnect my map sensor, and like clockwork, the light is on. So now I'm going to plug in my TinyScan, and it's going to read. Oh, I have 2 codes present. I have a 0113 code as well as a 0107. That's because I have my map sensor disconnected. The 107 is low voltage for the map sensor, and I have high voltage, which is the PO113, for my manifold air temperature sensor. So that's a brief overview of how this tool works, and you can see how quickly it is comparatively trying to make the check engine light flash and get the same codes. Okay? The last component I'm going to talk about at you here is our fuse block. Now, this device is mounted in a couple different areas. This can be found right next to the starter motor on the 810, and it can also be found inside the valley or the V on the big block engines. Now I'm going to take and remove the internal clip-in function here, and we're presented with a couple of fuses and a relay. Now, there's a 20 amp fuse here, which is this green colored fuse. Now that is in charge of protecting everything that gets 12 volt power on this circuit. So you got a fuel pump, fuel injectors, ignition coils, heated oxygen sensor. All of those are on this 20 amp circuit here. And those are also controlled by this relay. Now the relay that's over here is what we call a micro mini relay. Now if one of these things fails, you can get these from us from your source of supply. However, if you got to get one in a hurry, a local auto parts store will probably have the 30 amp version of this, and again it's called a micro mini automotive relay. The 15 amp fuse that's in over here protects our ignition circuit into the ECM. So when you have 12 volt power coming in from the key switch, it has to go through this fuse first, through the wiring harness, and then powers up the ECM. All right, so that takes care of the brief overview of our Delphi fuel injection system here.
Welcome back to Power Channel TV. Again, I have with me Tom Billigan, training manager here at Briggs & Stratton, and we'll go ahead and head into some of your questions. Matt from Vermont wants to know, I've heard that I can update the calibration in the field. Is that true?
Yes, it is true. You will need the laptop software dubbed the Electronic Technician Assistant. It works in conjunction with this diagnostic cable. The part number of that kit is 19628, and it is available through your source of supply, so your central distributor. Again, it's part number 19628, should be in stock, readily ordered. And that's how you actually update the calibration in the software with that program.
And our next question, Mike from Ohio wants to know, do you have the part number and the price for that tiny scan that you showed?
Yeah, the part number is 19626. Again, that's 19626, and the list price is $90. A little expensive right now, I understand, for just a code reader, but you know, we're going to start somewhere, and this is pretty small numbers at the moment. So again, 19626 on the tiny scan. That is available through your central distributor or source of supply, just like the cable currently.
And we've got Bill from Texas. Bill wants to know, do you have the price of the diagnostic software? Good question.
Yes, again, we kind of touched on this a little bit before, but the part number again is 19628 on the diagnostic software, and the list price, what you would expect to pay, was about $160.
And Stefan from Antioch wants to know, are there going to be more Briggs engines with this EFI system in the future?
It's a good question. Obviously, we're starting to get our feet wet with our pair of Vanguard V-twins here, but absolutely. There's already a process of development taking place all the way down to single-cylinder engines and how we can make it cost-efficient to do this. A lot of emissions concerns are going to drive us towards fuel injection here in the future, so we might as well be ready for it.
And we've got another question coming in from Russ in Twin Falls, Idaho. Wants to know, how do you flash codes? So Tom, I'm guessing he might be talking about, you know, resetting the codes or flashing the calibration. Maybe we could talk about both.
Okay. Well, in terms of the codes go, there's 3 different ways to get code information from these engines. There is the flash aspect, which I think you're referring to, where we engage a function here where typically you will key the engine on and off 3 times in a row. Actually, I need to have this off first. 3 times in a row, and on the 3rd time you leave the ignition on, and it will actually flash the check engine light. Now, I may have done it one too many times there, but there it goes. So it will blink out the code count to you, and in the service manual it explains how many counts equal what here. And this is the most base model way of getting codes. Otherwise, the tiny scan code reader, like I had used in the demonstration, is another way, as well as the laptop software.
And one note, you mentioned the service manual. Just wanted to mention that manual is downloadable as a PDF on the Power Portal, and it's also orderable from your source of supply.
Yes, you can order it as a paperback spiral-bound book here if you like to. It is part number CE8182. Again, that's CE8182. Your central distributor will have these in stock.
And our next question, we've got a friend up from Canada, Mike in Dawson Creek. Will there be a link to watch this at a later time? Well, Mike, yes, all of the Power Channel TV episodes, once we complete them, we get them placed up in our past episodes section of the Power Channel TV. So you'll be able to see every episode. This one will be up Monday morning. And we've got Rocky from Lakewood, New Jersey. What products will use this system?
All right, great question. The system is gone over with overwhelming success so far. There are so many, in fact, that we can't really keep up with demand all that well. The core products you're going to see this on, our own in-house Briggs brands, so Ferris, Snapper Pro. Some of the external customers, Husqvarna, Wright Stander, Hustler, as well as Altos. those are the big players right now buying that particular fuel-injected engine, and in reference to the 810 EFI specifically. Now, for the upcoming 2016 model year, you will find that we are going to be producing a big block fuel-injected engine for turf applications. So we've always had a carbureted version available, but now we're finally going to fuel injection. It'll be a 37 horsepower model there. And we're actually going to have a smaller one as available too in a Model 54, which is going to be about 33 to 32 horsepower.
And we've got another question coming in. Nathan from Loudon, New Hampshire. Is there a code book that lists DTCs?
Yes. When you get your Tiny Scan, if you order one of these, the instruction manual, if you flip it over, it comes with it. It's just a single sheet of paper. It spells out all 26 diagnostic codes, their number, a description, and a little brief presentation on what might be wrong. Also, the service manual itself highlights this too. In there, you're going to find that there is a code listing here. That's what you'll reference to. Again, there's about 26 different trouble codes that can come from this engine.
And do we have any other questions coming in? Looks like we don't. So thanks for attending another episode of Power Channel TV. We'll see you again next Friday. Again, 3 p.m. Eastern, noon Pacific.